Let's tackle this monster that's the inscribed angle. What is an inscribed angle? As it says, the sides of the angle need to contain chords. So like you see here, RQ, and then RS is another chord of the circle that forms the angle. And most important, where is the vertex? Right on the circle. Okay, when you have that, you have an inscribed angle. And with that inscribed angle, you get an arc associated with it called the intercepted arc. That's the arc that is contained right here. Inside, you'll notice it's interior to the sides of the angle. It's inside the angle. It's got the same endpoints that the chords pass through. That is your intercepted arc that you're going to be wanting to look at. So what's the relationship? What's so important about these inscribed angles? I'm going to show you a little demo here that's going to help you see that. So in this, we have an inscribed angle. You can see it's angle BCD and the intercepted arc there of BD. And I can do some dragging around. You'll notice that I can just say move this vertex C, move it. And when I do, it's got the same intercepted arc. B and D are still the endpoints of the arc that this angle is passing through. So that doesn't change. But let me show you the measures of these things. Now you get to see a little bit more. Our angle measure, 86.5 degrees. And notice how I drag that around and it really doesn't change at all. And so that angle stays the same no matter where, as long as it still intercepts the same arc. But when the arc changes, the angle changes with it. See how I'm making this arc smaller and smaller? And the angle is changing with it. So what's the relationship between the angle and the arc? That's our big question of the day. Take a look at some of these measurements. They're definitely not equal. Our arc is bigger than our angle. But is there a relationship that you can see? Let's just take a look at a few others. Some of these might be a little more obvious. What do you notice about these two measures? Let's look at a comparison of them in a fraction. The angle measure here and the arc measure, and I'll scoot this over. Right now, these two measurements are a half. So this angle here in green is half the measure of the arc it's intercepting. When I change that arc measure and the angle with it, notice right here, notice what doesn't change. It's still that 1/2 and it stays that constant value. I can make the arc small. I can make the angle and the arc very large, and it still is the 1/2 ratio. So what's the moral of the story? A theorem, the inscribed angle theorem. The measure of an inscribed angle is half the measure of that intercepted arc. So in our diagram here, if this is our angle measure, let's call it x degrees, and this is our intercepted arc across from it right here, we'll call it a degrees for arc. The x angle is always going to be half of that arc angle. That's the theorem. Let's use it in some examples. All right, here we're looking for angle x right here. And let's look at angle x and what arc does it intercept? If we draw these sides out, we can see that it's intercepting this 86-degree arc. So that means that our angle x is half of the 86-degree arc. It's always half the arc, which would be 43 degrees. And it's simple as that. It's a 43-degree angle. Now, we do that backwards here. We see this 52-degree angle here, and the arc it intercepts comes from y and out through x. So right here is our arc that it's intercepting. Remember, the angle is half the arc. So the angle measure is half of the arc measure. And so what's our angle measure? 52. That's half of our arc. So I'm going to just multiply by 2. Both sides of this times it by 2. And that cancels my half. That gives me 104 degrees for my arc measure. What might get complicated is when they draw a bunch of lines in this. So we really need to use highlighters and colored pencils to really look at what we want. So here's the question. Find this angle right here. Let's find the arc it intercepts by extending the sides and taking a look. It is arc DV. Arc DV is an intercepted arc. But do I know this arc? I certainly don't. I'm going to have to be thinking a little. But the only thing I do know is this 112-degree arc right here. All right, let's step back and look at this for a minute. What do you see about our red 112-degree arc and our blue missing arc? What's this called right here? Semicircle. How big is a semicircle? 180 degrees. So if the whole thing's 180, if we take away that red one, we should have the measure of our DV arc. All right, so calculating that out, you're going to get 68 degrees. So 68 degrees is this little arc, and the angle is always half of the arc. So my angle is half of 68, and that is 34 degrees. A little trickier. Looks like we're going for some algebra here. Let's find the value of x. So take a look. Your angle, this angle here is the only angle with an x in it that we know, and that angle intercepts this arc that takes me all the way from S around to W. Well, that's given in pieces, so we're going to need to know the whole thing. Let's just add those pieces together. We've got 17 plus 11 x's, so we're just going to say 28x, and then 3 and 7 make 10. So our whole arc is 28x plus 10. Remember, our formula for this is the angle is half of the arc. So our angle was 15x, and half of our arc would be half of 28x plus 10. Now you want to put that in parentheses because you're going to distribute. We're going to take half of 28, or 14x. We're also going to take half of 10. So we get 5 on that. So we've got 15x. This is not too bad. We're going to just subtract that 14x from both sides. That will bring us down to just 1x is equal to 5. Not bad on the algebra. More algebra. Sweet. Can't get enough of it. Okay, so here's our angle. Here's our angle. Coming from our angle, we see our intercepted arc here. So let's use our formula again. We're going to put in our angle, set it equal to half of our arc. Okay, so the angle is 8x plus 1. Bring down that 1/2, and our arc is 17x minus 3. On this one, I'm going to show you a different way to do this. Sometimes this fraction, you can handle it different ways. In this one, I'm going to multiply by 2 on both sides. So let me double that. That'll cancel the half. And the reason I'm doing that is because I like to distribute a 2 a lot easier than a 1/2 usually. So this is just an option. You can certainly do it like we did the last example. Multiplying the 2 through gives me 16x plus 2, and then that half is canceled, so I'm just bringing down 17x minus 3. All right, let's get rid of the 16x's on both sides. That's just 1x. And let's add 3 on the other side. 1x equals 6. Okay, now I'm boxing my answer, but I just noticed that the question is not to find x. It's find the measure of arc QS. We are not finished. Just when you thought you were done. Okay, you know how to do this. We're going to substitute our 6 in for that x. So we want 17 times 6 minus 3. What is that? That's a whopping 99. That is still not the question we're supposed to be answering, though. We need this segment right here. How do we get this? Do you see the semicircle I'm seeing? That was a diameter, so semicircle. Our final step is going to be we need to simply take 180, our semicircle measure, and subtract our 99. And so we get 81 degrees for that measure. Moving on, we have some corollaries. Now remember, corollaries are just, they're like theorems, but they just follow directly from a theorem we already know. So these are pretty easy to get and understand if you understand our inscribed angles theorem. Corollary number 1 talks about 2 inscribed angles, but they're intercepting the same arc. So we're going to draw a picture of that. Let's draw one angle, and let's say we're going right here. Now mark the arc that is intercepting. I'm going to do that in a highlighter. This is our intercepted arc here. Now the second angle I draw needs to intercept the exact same arc. So on this one, I'm going to come from this point, but I'm going to come out through the exact same points that it was before. Okay, let's call this angle number 2, and let's go back and call the first one we drew angle number 1. What we're saying here is because they both intercept the same arc, this is like in that demo I was showing when I was dragging the angle around and not changing the arc. These are congruent angles. Nothing changes about those. So angle 1 would be congruent to angle 2. Corollary number 2 talks about an angle that's inscribed in a semicircle. So we're going to sketch that too. We've got a diameter drawn in. If we pick a point on our circle and let the sides of our angle come out at the ends of this diameter, so there's our angle. And since it's inscribed in a semicircle, here's the semicircle, what do we know about the measure of that angle? Well, the semicircle always has 180 degrees in it. And since this angle is inscribed, it's going to be half. So we know that this is a right angle, half of our 180 every time. And our final corollary talks about these an inscribed quadrilateral. You'll notice the vertices are all on the circle. And specifically, it's referring to the opposite angles of that quadrilateral. So let's number a couple of those. Let's call this angle 1 and opposite of it right here, angle 2. Those two angles are what we're talking about. Well, look at the inscribed arc. For angle 1, the sides come out at this point and this point. So here's our arc that is inscribed by angle 1. Let's just call that arc number 1. Angle 2 is inscribed from this point to the same point. So right here, this is our arc number 2 for angle 2. Well, what do you notice about arc 1 and arc 2? Arc 1 plus arc 2 together, they make the whole circle. They're making 360 degrees. What does that tell us about the angles? The angles are half of the arc. So angle 1 plus angle 2 is going to be half of 360, or 180. Angle 1 and angle 2 are always going to add to 180. So that's your corollary. The opposite angles of an inscribed quadrilateral are always going to add to 180 or be supplementary. And these corollaries give you some nice shortcuts that when you face problems like this one. So we're going to look for angle QT. Oh, isn't it cute? It's a cutie. Huh. All right, here is arc QT. I should have said arc. And we want to know the measure of this arc. Well, the given information is about angles. Notice that angle S is an inscribed angle. Where do its sides come out? Right through Q and T. Therefore, angle S is half of QT. But also given to us is this angle here, and those sides of that angle also come out at Q and T. So this is our first corollary. Angle R and angle S must be congruent. They both intercept the same arc. So let's just set them equal to each other. Our 12x minus 13, and set that equal to 9x plus 2. And you can do the math from here. Why don't you pause the video and take care of the rest of this? Okay, you can check my algebra against yours. You should have gotten x equals 5, but we're not done. We've got to get the arc measure, so we need to substitute that back in. Let's go plug our 5 in, say right here. So 9 times 5, that's 45, and then adding 2 to that's 47. So the angle is 47. The arc is twice that size. So 2 times 47 for the arc. 94 degrees is the final answer. Okay, in our next example, we've got an angle R to figure out. The given information is again some algebra. What do we know about the picture? Notice that you've got a diameter right here, and therefore what kind of an angle do you have? When you look at this inscribed angle, I'm going to show you the arc it inscribes. The arc it inscribes goes from R clear around to S. That is a semicircle. So what do we know about this angle, 5x? We know it's a right angle. There's an equation we can use. The 5x measure is the same as a 90. So 5x equals 90 tells me that x, when I divide, is 18. Now don't stop there. Angle R is the question. So how can we get angle R? What do we know about angle R? Let's follow out its sides to where it's intercepting this arc. The arc it intercepts is the QS arc. So QS, if we plug in the 18 we found for x, that's going to be 108 degrees. The angle R is half of that 108 degrees. So angle R would be half of 108 or 54 degrees, and that is our final answer. This final example gives us a quadrilateral inscribed inside the circle, and so I want to show you how that third corollary helps you out. What we're going to look for is this arc from K to X, but I want to find an angle I can associate with it. So you might start by looking here at point K on the arc. Let's find one of the chords that comes out through K. I'm going to come down to V. And then if I follow another chord out from there, I get a good angle. Angle V is inscribed, and this is its intercepted arc. It goes all the way around K to W. Now we know that angle V is going to be half the measure of that, but we don't know what the measure of that is. What we do know, however, is that this angle X right here is a supplement to angle V. So if I take 180 and subtract 78, I'm getting angle V. That's 102 degrees. So 102 for angle V. Now using our theorem, we can say that this arc across from it is twice the size of that. So multiplying that by 2 gives me a measure of 204 degrees for this arc. Finally, I just need to figure out the arc, the piece of that I'm missing. So if the whole thing is 204, let me subtract off the 140 degree piece of this arc, and I'll get my final answer of 64 degrees. I like these kind of problems, and actually I'm going to leave some of this for extra credit for you. I know I only asked for one arc, but if you can find the other two arcs that you don't know, as well as the angle W, and show me in class tomorrow, I'll give you extra credit. That's right, I said extra credit on your packet.